Hey everyone, welcome back to the Immersive Limit YouTube channel. I'm Adam Kelly. In this video, we're going to go through training MLAgents, and we're working with MLAgents release 10, which just came out in November of 2020. So hopefully this is relevant. If you're watching it along, far in the future, I hope that by going through the documentation while I do this, this can still be helpful. So in the previous video, we went through a bunch of examples in the MLAgents repo. And in the video before that, we went through installing MLAgents with Unity. So if you need help with either of those two, make sure to check out those videos. We'll make sure to link them in the description. But for this one, we want to train something. And I figure we can try training this tennis example. So if you don't have it open, you can open up the tennis example project. You just go to the scenes and you double click on tennis and it'll open it up. Now it is pre-trained, so if I play this, it's going to work. And the reason it works is because each of these agents has the model here, this neural network model is filled in. So if we did not have a model, for example, if we created this from scratch, then there would be no model here and we would be required to do it. We couldn't just press play and have it work. So that's what we're going to do, is we're going to try and create our own model using Python to train it. So first you need to make sure you have Python working. Now in the 2 videos ago, I talked about getting Anaconda installed. So make sure you have that. I'm going to quit to get out of this Python interpreter. And what we're going to need here is the MLAgents Python packages installed. And so let's go to the documentation. And I am in this MLAgents release folder, which we downloaded in the previous video. Under docs, I'm on the installation page. And there is mention of these 3 Python packages. So these are the things we need to have installed. So we can scroll down and hopefully it tells us how to do it. So it says installing the MLAgents Python package involves installing other Python packages that MLAgents depends on. So you may run into installation issues. So yeah, that's entirely possible, especially if we're using older versions. The unfortunate thing with Python is when you install stuff, there are dependencies that can break, and it's just the way of things. Python, just like any other software, evolves and things break, but ultimately it gets better. So we're going to install, it looks like we need to install PyTorch. Well, let's start with Anaconda here. We need to create a new environment. So I'm going to type in conda create -n. So this is a name that we're going to give it, and I'm going to give it ML-agents _ R10 for release 10. And then I'm going to type Python equals 3.7. And hit enter, and it's going to ask me if I want to proceed. I'm going to hit Y and hit enter. And I don't know if I can make this any bigger. Properties, can I make this larger? That's a little bigger. Hopefully that's easier to see. Okay, so to activate the environment, we use this. So I'm going to drag over this, right click to copy, right click to paste, hit enter. And the commands for Linux or Mac should be fairly similar to this, but might be a little different. So now we've got this repo, and it wants us to install Torch. So let's copy this. I'm going to Control C, and I can right click in here, and hopefully this works. So it does appear to be downloading, which is a good sign. So I'm going to let this finish. Okay, so that seemed to work without any issues, which is good. And we go back to our installation instructions. Mentions needing Visual Studio or Visual C++ redistributable. I bet I already have that installed, so just make a note of that in case something didn't work properly. Then I need to install MLAgents. So let's do that. And this seems to be working well. The one thing I will mention is that make sure that if you're doing any of this, that you are in, hold on. Make sure that you see this right here. If you're in Anaconda, make sure you're in the right environment when you're doing this, or else this might not work properly. So what happened here? So it's telling me that the error is about pip changing, and it says that MLAgents envs requires numpy less than 1.19.0, but you'll have numpy 1.19.4, which is incompatible. All right, so this actually happened to me a few days ago for another project I was doing completely unrelated to MLAgents, but good news for you because I know how to fix this. So what we need to do is uninstall the version of NumPy that we have. So we have to do pip3 uninstall NumPy, and we'll say yes. And then we need to do pip3 install, oops, make sure we spell that right, install NumPy equals, and then we have to give it a version. So it needs something less than 1.19. So I think we need to do if I remember correctly, it was 1.18.4 that worked for me. But here's a little trick. If you search for NumPy versions, then you can go to this PyPy. And so this is where, when you do a pip install, this is where it comes from. It comes from this pypy.org. And we just need to figure out what the different versions are. So we can go to release history. This is the current version. And this is the one that it's saying it's too high, it's not going to work. And it needs to be lower than this one. So the next one up is from June 3rd. It's 1.18.5. So we can change this to 1.18.5 and hit enter. And then we've now installed that version, and we should no longer have a compatibility issue. This should work properly now. So I'm gonna try and run that pip install MLAgents again, and just make sure that nothing red came up. So it just says requirement already satisfied. So we should be good to go there. And where am I going? Okay, so back to the installation instructions. We have that installed. And advanced local installation for development. I don't think we need to do this. If we were trying to modify any of the Python code, then this would be the way to do it. But we are using the version from PyPy. So if you do need to modify the Python code, or you need to be absolutely sure that you're using the version that's inside of this directory, then these are the commands you would use. So we're going to skip over that. We're not going to do that. And then it tells us we're done. We can go to next steps, getting started. So this should be set and ready for training. I'm going to scroll up to the top. Maybe I had already opened this or something. So this getting started guide, I believe, actually walks you through doing installation, understanding the environment. Let's see, what else does it do? And then running a pre-trained model. That's cool. We already went through that. And then training a new model with reinforcement learning. Okay, so this is what we want to do. This teaches you how to do it with 3D ball, but maybe we can adapt this to work for the tennis one. So we need to open a command or terminal window. Well, that for us is going to be this Anaconda prompt. And we make sure that we're in our MLAgents R10 environment. And if for whatever reason you are not in this, like if we were to close this down, well, I'll just open another one, and you see it's in base, then you can do conda env list, and it'll give you a list of all your environments. This is the one that I want, so I'm going to do conda activate MLAgents underscore R10 for release 10. Okay, so that's how you get back there if you get lost or something. So the commands that it's looking for, it wants us to navigate to a folder where you clone the MLAgents repository. Okay, so we need to go to, where did I put this? Documents, code, MLAgents, cd documents, code, MLAgents, and then I'll just do a dir to list out which directories I want to go into release 10. So I'll do cd ml-agents-release 10. Okay, so I'm in that directory. Then you should be able to run MLAgents-learn from any directory. Okay, so if they want to do this 3D ball thing, so let's take a look inside the config PPO directory. Config PPO, and 3D ball's there, but let's see if we can find the tennis one. Okay, so tennis.yaml. So we're going to run the command. I'm going to start typing this in here. MLAgents-learn config/ppo/tennis.yaml. Let's just double check tennis.yaml. Yep. And then it wants us to give a run ID equals first 3D ball run. So we can give this whatever we want. So I'm going to do -- run. Is it run -ID? Yep. And then we just give it equals, I'll call it tennis_01. Okay. And we should be able to run it. And then it's going to say when the message start training by pressing play in the Unity editor is displayed on the screen, you can press the play button in Unity to start training in the editor. Okay, so we're going to hit enter. And I'm going to allow access through my firewall. And it looks like it's warning me that my NVIDIA driver is too old and I need to update my GPU driver. So I might need to do that. We'll see if it works anyway. So it says start training by pressing play. So we'll go to the Unity editor and we will press play. And you can see right away that it's definitely not playing tennis like it was. It looks like it's raining tennis balls here. And there's a lot of points being scored because no one's actually hitting the ball back and forth. So at this point, we see some stuff popping up. We're starting to see the step that it's on, the time elapsed, and the mean reward, the standard deviation of reward. So this is the training. It's going right now, and it is training these agents, all 18 of them times 2. So what is that, 36? Forgive me if that's wrong. So it's training all of them simultaneously, and then we're seeing the results of that training here. And you can see they're not doing very good. They're just getting negative rewards. That's the average, the mean. And you know, we got a slightly positive one, but I'm not sure how long it'll take to get up to a higher reward. You can view graphs of this in tensorboard. So while this is training, maybe we can look at that really quick. I don't know if they show tensorboard. Here we go. So we can do this. So if we follow these instructions, they basically want you to hop into the same directory. So I'm going to, if I middle click on this, it opens another Anaconda window. So I'm going to, let's see, conda activate. I should have left that open. ML-agents underscore R10. And then I have to go into my documents. Whoops, not Docker. Documents. Take off caps lock. Code. Where did I put it? MLAgents. And then release 10. Okay. So it wants us to run this tensorboard -- logger results. And just to point out what that's actually doing, it's looking inside this folder, which you can see that there's tennis results in here now because we've started training tennis. So if I run this command, I'll copy this and paste it in here. TensorFlow installation not found. Well, I'm not optimistic that this will work, but let's see. Go into the browser, paste this in. Oh, it's working. It must be because they're using PyTorch now that they don't need TensorFlow installed, but they're still using TensorBoard to view the results of the training. So we're seeing here what our cumulative reward is over time. So it's been training for about, if you look in the black box, for about 2 minutes and 35 seconds at this point. It's hit step 150,000, and the cumulative reward is pretty bad. So it's going to need more time to train, and the episode length looks like it's going up, but we'll see if that actually continues going up or if it goes back down. So this is TensorBoard. It's just a little bit easier way to view rewards and things like that. You can play with this and make it bigger, things like that. So there's something here for self-play too, which is something I haven't actually explored myself, but it looks like, I don't know why that box won't go away, but it's got its own graph for how well self-play is working. So that's kind of cool. Let's see what's next. So this is going to keep training, and we can talk a little bit more about that YAML file in the meantime. So it shows this. This is what showed up when we started training. This is showing what it looked like in the documentation for ball 3D. And it shows what the hyperparameters are that were used to do this training. So hyperparameters are like settings for your neural network. So you set things like how fast it should learn and how long it should train and how complex the neural network should be. And there's a bunch of different things in here. There's documentation within here, within docs, that explains all of these things. Let's see, is it under training MLAgents? It's somewhere in here. I don't remember exactly where it is, but it's in one of these. We will open up the config though, and we can take a look at what the hyperparameters were for tennis.yaml. So I'll open that up, and this is what it looks like. So tennis.yaml has all of these different hyperparameters set. So this is determining how training is going to work, and network settings. So that's the neural network. We have 256 nodes in 2 different layers. And this tells it what kind of rewards to use, how long to train for. It's got some stuff about self-play. So if you're working with your own, if you're looking to create your own MLAgents project, what you should do is pick one of these existing examples and look at what these behaviors are set up to be for that. So like the 3D ball, this one, and I'm going to just swap between, like, look at the batch size. It's different. The buffer size is different. The hidden units. So this is the number of neurons. It's more complex neural network. It probably doesn't have any self-play, I'm guessing. Yeah, no self-play. So this, while it's a little overwhelming at the moment, is how you determine like how the training is going to take place. So this is definitely important, and you'll need one of these for your own custom neural network. And so I just wanted to go through that in a little bit of detail. And I'm going to stop being lazy and figure out where the documentation is for this. So let's see. Training configuration file. Yeah, it looks like this is it. So this training configuration file .md, which is inside of our docs folder, training configuration, this is going to explain what all of these different things are. So if you're wondering, let's pick one of these. So batch size, for example. This one was 2048 and the buffer size was 204080, so 10 times higher. And this one was 64 while the buffer size was 12,000. So why would that be? Well, let's take a look here. So we want to find buffer or batch size and buffer size. So it's in here somewhere. Did I go past it? Well, let me do a Control F. Batch size. Okay, so here we go. Batch size. So it's the number of demonstration examples used for one iteration of a gradient descent update. If not specified, it will default to the batch size of the trainer. So it's right here, we're telling it how many different experiences to gather before it does an update of the neural network. And then if we look for buffer size, then it says the number of experiences to collect before updating the policy model. Corresponds to how many experiences should be collected before we do any learning or updating of the model. This should be multiple times larger than batch size. So, whoops, I did not mean to do that. Typically, a larger buffer size corresponds to more stable training updates. So that's why you'll see they've got this typical range for PPO, which is what Tennis is using, PPO. It's doing a multiple of the batch size. So, I can't explain exactly what all of this means in this context right now, but if you want to dive a little deeper and understand all these different parameters and understand why you might want to change the beta, for example, then this is where you want to go, the training configuration file. And just make sure that if you're using PPO, that you're looking at the stuff that's relevant to PPO. If you're using SAC, that you're relevant to SAC. And PPO means proximal policy optimization. SAC is soft actor critic. So I'm not sure where they might show that, but sometimes it's hard to look up 3-letter acronyms, so I figured I'd let you know. So let's just check back in on this. Don't even think it's updated for some reason. Let me see if I can refresh this page. Okay, so look at that. That looks way better. It looks like it has started to learn. The episode length is now getting up to 23, which I don't know if that's seconds or probably. So let's take a look at Unity. And it looks like they're actually managing to hit the ball back and forth a little bit. They're still not having a great game exactly, but they are starting to get points, which is great. So this will probably take a while longer to train, and you'll see that this continues. I do want to mention one thing. If you accidentally click in here while it's training, it kind of messes up. So if that happens, hit enter and it will resume training again. So that's just a quirk of the command line that has caught me many times, and I always think it's worth mentioning. So what we'll do is we'll just let this keep on training and see how well it does over time. It looks like it's definitely trending upward. And in the YAML file, it's set to do a max steps of, what is this? 50 million steps. And right now we've only done just over 500,000. So this is going to go for, another 25 times longer than it already has if we let it go all the way. Now, what's more likely to happen is at some point, it's going to level off. And the cumulative reward and the episode length will kind of flatten. And at that point, you can stop it manually. And then you'll get a result that you're looking for. So go ahead and let this train, and we'll come back once this has trained to a point where they're doing really well. And then we'll stop the training, and I'll show you how you can import your new neural network model into Unity. Okay, so this has been training for a while, and you can see that the cumulative reward isn't like amazing here. But the environment length, or the episode length, is doing pretty well, meaning that the ball is staying in the air longer than it started. And so we can take a look at this and see what's happening. You'll notice that they're moving really fast, and that's because it trains at faster than real-time speed. So if we go to Edit, Project Settings, and I'm going to drop this tab over here next to the inspector, you can go to the physics, and I believe, or sorry, it's under time, not physics. Timescale is set to 20. So while it's training, it doesn't hurt to change the timescale back to 1. And you can see that they're managing to at least hit the ball across the net when it drops on their side. They're not great at hitting it back and forth, but it's certainly better than it was when it started. So, of course, if we wanted to train this to as good as the version that came with the project, then we would want to let this keep training. But I'm impatient right now, and I want to wrap up this video, so I'm going to stop this now. And the way I like to do it is just hit the play button. And back in our Anaconda window, you'll see that it stopped training. And let's see, it says converting to results tennis _01 tennis dash 1023836.onnx. And it looks like it just, and then it says it copied this to this file here and saved the model. So the TF models that are here, this is a .nn file. So we want to figure out where the .nn file is. This is a little different than the last time I used it, which was a few months ago. So we're going to take a look inside this results folder, which is hopefully in here. Yep, results. And we have this .onnx file here. And I don't see any .nn files. So let's go back to the instructions here and see if we can figure out. I'm in training MLAgents here. Is this? Let's go back to the getting started guide. So if I go to in the preview readme.md right now, getting started guide. So this one here, if you're looking for it, is in the docs under getting started.md. It tells you to train the model here, and then after tensorboard, embedding the model into a Unity environment. So once the training process completes and the training process saves the model, let's see, what does it want us to do? We can either resume it, or your trained model will be at this whatever .onnx. So we need to move our model into TF models. So they must just support both of these now. And then we want to select the 3D ball prefab agent, drag the ONNX into the 3D ball agent, press play. Okay, so let's give this a try. So we're going to, I think this will probably be the easiest way. We'll take this ONNX file, which is probably pronounced Onyx, and then we're going to click and drag this down into here. And I'll just rename this just so that we don't confuse it. _ONNX. Okay, so this is our trained version, and you can see that here. This is the original one. If you wanted it to come in as a different name, you could rename it here before you dragged it in. And then, why don't I just pick all of these and just, in the inspector, I'm just gonna switch these off. So we've just got this one area. And then I'm going to swap out the, where is it? The model here. And I'm gonna find the tennis ONNX. And I'll do that for agent B here too. And we'll do this. Okay, so now we've got this model. And if we press play, since it's set to default behavior type, it should, since there's no trainer attached, this is now using our newly trained worse agent that we just made. But you can see that it's way better than just the default of, the ball just falls to the ground and it doesn't do anything. Okay, so now, just for fun, let's make agent B use this model here. And I'm guessing agent B, the purple one, will always win. And we'll be able to see that. So blue, oh, purple, really good, perfect. Oh, blue's just, oh, blue, come on, get with it. So that's some fun you can have too. You can see that purple's just gonna trounce this blue player here because it has a better trained neural network. So that's actually something you can do in your own projects. If you train agents to different levels, you'll find that their skill levels are way worse. So maybe this brain that's used, this neural network, is used for a more challenging opponent, and something like this is more for an easier opponent. So if you have people playing your game, they can pick how good they want their opponent to be. So that's just kind of a cool feature there. And now you have an idea of how these models can be added into your project. And what's cool is if you build your project now and you exported it as a game or you put it on your mobile phone, then this works inside of that project. You don't need to do anything else that's special. You can just deploy this. And I even deployed my airplane game to itch.io. And I haven't been there in a long time. .io, immersive limit. Let's see, I haven't been here in a long time. So this game, I actually uploaded to the web, and the airplanes that are in it are trained neural networks. Okay, so I'm right here. These other planes here are neural networks that are trained, and they're running in the browser. So no Python hooked up or anything. They're just trained agents. So I don't need to keep playing this, but I just wanted to show you that. Hopefully this was helpful. Hopefully it got you up and running with some training. You'll find that with your own projects that you spend a lot of time checking these graphs and being very disappointed because they didn't really train. You'll see something like this, and maybe it seems like it's going up and then it goes down and never goes back up again, things like that. Don't get too discouraged. These example projects that Unity included are clearly both simple and well designed and honed to a point where they work every time you train them. It's just a matter of time. With your own projects, you'll find that you have some weird bugs. You might find that your agents exploit physics or whatever. If you give them a way to cheat, then they will take it almost every single time. So, just have patience and experiment and have fun with it. And eventually you'll get some agents that are behaving the way you want. Thank you so much for watching. Let us know what you thought in the comments, and we'll make sure to come back with some more MLAgents content, probably some more custom new projects that you haven't seen before.